Now let's take a step into the future. A future where data isn't a byproduct, it's a first-class citizen. It's something we trace, we trust, and we use to drive execution, not just estimate it. And no, I'm not talking about fancy dashboards layered on top of poor quality data. Too often we see Power BI dashboards built on incomplete, disconnected, or inconsistent data, and then we wonder why it doesn't scale. Why can't we drill deeper? Why can't it connect to 3D? Dashboards aren't the solution. Clean, structured, connected data is. So what does that mean? It means rethinking how we connect the physical and functional worlds. It means managing data at the tag level, assigning work, tracking change, enabling readiness. A tag isn't just an object anymore, it's a unit of execution. Now let me give you some scales. We've supported 7 or 8 major FPSOs using Konnect XD. Big boys, not small ones. These are ships with 150 to 300 systems, 5,000 lines, 15,000 isometrics, 50,000 spools, and 150,000 welds. Big numbers, yes, but they're still manageable. This isn't big data in the modern tech sense, but for a project, it's brutal in complexity. And things can spiral out of control quickly, especially if you're waiting on delayed inputs from engineering or procurement. Because while you're waiting, you can't scope work. You can't plan resources. You can't hire or retain the right people. You're stuck. Now imagine a world where every tag is traceable. Changes are captured in real time from engineering, from the field. Work fronts are clearly defined. I like to break down work fronts into 3 simple buckets. Planned but unavailable. Planned and available, that's the sweet spot. Available but unplanned. That's risk it could perish in laydown or become idle stock. And here's the truth. Construction doesn't operate at a daily rhythm. You have to plan weeks in advance just to move the needle. And that planning is only possible if you have data you can trust and relationships you can track. That's the gap we're trying to close with our model by maintaining traceability between the functional world, tags, systems, drawings, and the physical world, spools, supports, assemblies. Because today, that traceability is lost in translation. Everything is analog. Lists are Excel files. IFC revisions, you can barely trust the first one. Now look at the diagram on this slide. At the top, we're reconnecting the dots. Systems, isometrics, spools, painting surface areas, testing volumes, total weights. This curated data is not a luxury anymore. It's the new standard for quality and readiness. Below that, we show the physical world and the functional world and how they're typically disconnected in our traditional tools. Piping is modeled in one CAD system. Spooling happens in another 2D tool. Steel structure is done in yet another software. And the kicker? Steel supports for piping are not even reconciled in your base model. Why? Too heavy, too complex. The STP files are dumb geometries, B-reps without intelligence. And so the support structure and the piping model remain strangers. That's where Konnect XD steps in. In this image, our platform has connected a pipe to its support, the support to the steel beam, and the beam to the structural hierarchy. Without Konnect XD, that relationship is completely invisible, unless you manually open drawings, verify revisions, and pray they're right. One of our clients gave us a real challenge. Their steel model and piping model were out of sync. They needed us to detect the differences not with clash detection, but something more intelligent. So we built physical relationship checking. We don't just look for overlaps, we look for what's connected and what's not. We can immediately tell when a pipe support isn't connected to a beam not because of a geometry overlap, but because the data says it's not. Instead of clash checking, we're doing void checking. We're verifying what's missing, what's disconnected, and closing the gap between design intent and construction reality. This is the execution-ready model we believe in. It's not just digital, it's data-driven. It's not just pretty 3D, it's functionally and physically connected. And it's built to help the people who build the project. All right, let's talk tech for a moment. At the core of this whole model, this new way of working is one thing. Trust. And trust starts with data. Not dashboards, not promises, data you can believe in. It begins with proper data ingestion. You need solid pipelines, structured, repeatable, and robust. Then comes cleaning and normalization, getting rid of noise, gaps, duplicates, errors. Then you analyze, validate, and only then can you begin to simulate anything meaningful. Today, most simulations in construction are still guesswork. We simulate based on assumptions. We run what-if scenarios on top of shaky baselines. But imagine simulating based on the actual conditions of your project by tag, by test pack, by system readiness. This is the shift, from firefighting to foresight. From looking in the rearview mirror to seeing what's ahead with confidence. That's exactly what Konnect XD was built to support. Under the hood, it's constructing thousands of relationship graphs, not just geometric, but business-driven. We connect progress, quality, and completion data across disciplines. So when a valve is delayed or a test pack is rejected, the impact flows through the system. It's about traceability, context, and connected decisions, not just reporting. And with that level of visibility, you unlock not just analytics, but true predictive power. Let's stay with trust for a second, because without it, nothing else matters. We've all been there, chasing down the latest revision, discovering too late that a spool drawing was outdated, even though fabrication was already done, realizing after the fact that the numbers didn't add up. Without structured ingestion and quality control, your entire software stack, no matter how beautiful, is just a house of cards. That's why we start with data pipelines. Not flashy dashboards, not AI. Just reliable foundational pipelines designed to handle engineering data, construction tracking, material progress, and detailed MTOs. Once the data flows in, we enforce quality gates. We ask, are the tags consistent? Are the relationships intact? Is the 3D hierarchy valid? Is the model complete, accurate, and trustworthy? Does the metadata, like P&ID numbers, follow the naming convention? Are we seeing clean data from the 3D model or chaos in disguise? These are simple questions, but most projects don't have the tools or workflows to answer them with confidence. So we built them. We built pipelines and dashboards that give you precise workflows where you can split and merge data, clean and transform it, and automate checks. No AI required yet. Now let me ask you something. How many of you have actually seen a real-time evolution of your project's material takeoff over time? How many of you can compare two projects and say, yes, we progressed from model review 0% to 30% to 60%, and the numbers tracked and made sense? That's the level of visibility we're aiming for. That's trust. All right, this next slide is a big one. Maybe the most important slide of this presentation. Why? Because it's about change. And if you've been part of any major project, you already know. Projects change every single day. Yet somehow we still treat change like it's an exception. Something to log manually, something to email about, something to bury in a transmittal or flag in an Excel sheet that no one fully trusts. And we've got armies of people trying to chase it down. But the truth is, we're overwhelmed. There are too many people looking at the same issue, and still no one has the full picture. Because we're not managing change, we're barely surviving it. So here's the shift in thinking. Change needs to be captured at the data layer. Let me explain. Take a piping line. It gets rerouted. You don't need a designer to send you a PDF. You just need the metadata to change. The tag has moved, that's it. Or the spec changes. Or a vendor drawing comes in with new dimensions. These changes ripple not just across disciplines, but across activities, systems, and even schedule. This isn't just about tracking what changed. It's about seeing how change impacts everything. What work needs to be redone? What progress is now invalid? What systems are affected? What scope just got bigger? This is where control comes in. Traceability is great, but what we really need is control. Control of scope. Control of impact. Control of time and resources. Because too often, we only realize the effect of a change when we're burning overtime. Scrambling to update reports, realign teams, and shift priorities. Let's flip that. Let's capture change as it happens. Let's reconnect the dots, from the functional intent on the P&ID, to the physical system, to the real-time state of the project. That's how we stop firefighting and start leading. So let's talk simulation. A system like this, one built on trust, quality control, and traceability, isn't just for reporting. It's designed to simulate. And this isn't science fiction, this is now. You can simulate system completion readiness, spool delivery timelines, test package maturity. Imagine being able to say, this test can't go ahead next month. 2 spools are pending refabrication due to a new version of the isometric drawing, and we will be able to execute line check on week 34 as resources will be free, and the spools should be installed and QC released on time. That's not a spreadsheet guess. That's real-world logic flowing from real project data. This is where simulation evolves from a planning tool to a command center capability. It's not about pretty charts or theoretical curves. It's about making operational decisions in real time with confidence. We all know S-curves. But what if we could actually look ahead? Not just track what's been done, but predict what's going to be ready. That's the shift. From looking back to planning forward dynamically, accurately, and at the level of tags, systems, and workfronts. Let's talk about competitive advantage and how data, simulation, and decision-making create it. This chart is based on the familiar S-curve. But it's not just about tracking progress, it's about understanding performance. And more importantly, how to optimize it. Because let's be honest, if project execution was just about being tidy and organized, we wouldn't be here. This is about competition. Yards compete for the same fabrication contracts. EPC companies compete for the same clients. Everyone is under pressure to do more with less. And in this race, the winners aren't just efficient. They're the ones who've mastered their data. Now look at this curve. On the orange line, you have a traditional execution path based on static planning, fragmented information, and manual recovery from delays. You'll still get there, but slower, less predictably, and with more pain along the way. But now shift your mindset. Start by organizing your data from engineering through commissioning. Track every tag, every spool, every system, and connect them across disciplines. When you connect data, things that were once invisible become clear. That pipe support? It's holding up a spool from a different discipline. That fabrication delay? It's tied to material not yet released. That test? It's blocked by 2 upstream welds, still waiting on manpower. This isn't theory, this is your competitive edge. That's the green line. The green line represents a project where you plan for work based on real readiness, simulate scenarios before decisions are made, and you accelerate with confidence, not guesswork. And that green space between the orange and green curves? That's your optimization zone. That's profit margin, schedule certainty, and reduced risk exposure in one visual. Now let's bring this home. Fabrication yards, whether in Asia, the Middle East, or Europe, are running multiple projects at once. But they only have one fab shop, one line, limited warehousing, limited manpower. It's not a car factory with infinite throughput. It's a complex, resource-constrained environment. Simulation allows them to forecast capacity, allocate smarter, subcontract with precision, and avoid chaos. Not every yard can do that. Not every EPC can provide that level of clarity. But the ones that do, they win more projects, they execute faster, they reduce risk. That is the true competitive advantage. Let's take a moment to talk about AWP, Advanced Work Packaging. It's a powerful framework. But let's be honest, in many projects today, it's become just another structure layered on top of the chaos. AWP was meant to bring clarity and alignment over FL through engineering, procurement, construction, and commissioning. But the reality is, when our processes are still analog and our data is still disconnected, AWP starts to feel like a rigid layer, a structure without substance. Now don't get me wrong, AWP is important. But without clean, connected, real-time data, AWP planning only delivers an illusion of visibility. You can have the best process in the world, but if your data isn't ready, you're planning on sand. So what's missing? What's missing is digital continuity. Not more packaging, not more structure. But flow, real-time data movement from engineering to procurement, fabrication to installation, commissioning to startup. AWP tends to speak in packages. But reality happens at the tag level. That's the narrative. We need a tag level story, not just a package level plan. Because in construction, we don't just need better plans, we need better adaptability. Plans break. It's the nature of the job. Too often, we start with well-intentioned planning only to watch those plans turn into massive cost breakdown structures, instead of meaningful work breakdown structures. And then what happens? Startup and commissioning teams are handed over a USB stick full of folders, drawings, document hierarchies, and left to figure it out on their own. It's not acceptable anymore. This is where digital thread and data-centered continuity matter. We've been talking about these ideas for a decade, but now we have the technology and platforms to actually deliver it. To shift from efficiency to resilience. That's the real promise of AWP when powered by digital continuity. You don't just plan, you adapt. You don't just schedule, you simulate. You don't just track, you pilot. AWP can be strong again, but only if we stop using it as a static framework and start using it as a live connected system. Because today, most planning tools, even Primavera, have become reporting tools. We're building 30,000 line schedules with macro-level dependencies that have no relationship to reality on site. Meanwhile, owners and operators are still asking for cost breakdowns, while EPC companies struggle to map the actual project work into those formats. Why? Because we lack the tools to translate between planning, execution, and delivery. So no, this isn't about abandoning AWP. It's about taking it beyond AWP into a world where data enables planning, not the other way around.